Welcome
Yang
Pak Jamalun Laili, Pak. Welcome to our
Yeah.
seminar. Thank you very much for your time.
Can we start the international webinar, Ibu Laili? Professor Heiki already joined with us.
Oke, silakan Bu Lianda, dimulai.
Baik, mohon izin Pak Rektor dan Pak Dekan.
Yeah.
Good afternoon, ladies and gentlemen. My name is Lenda Rechmadeni. It's a wonderful and precious chance for me to be your master of ceremony in this international webinar, Becoming an Engineer, on Friday, 13th of August 2020. First of all, I would like to welcome the honorable speakers in this event. Professor TPR Dr. Jamalun Laili Abdullah from Faculty of Architecture Planning and Surveying, University Technology Mara, Malaysia. Good afternoon, Prof. Jamal. Thank you for joining. And Professor Heiki Kosuke from Department of Earth and Planetary Science, Earth and Planetary Dynamic, Hokkaido University, Japan. Good afternoon, Professor Heiki.
Hello.
Nice to meet you, Professor. And the next speaker is Dr. Muhammad Safiq from Supply Chains and Project Management Center, University of the Punjab, Pakistan. Good afternoon, Dr. Shafiq.
Yes, good afternoon, everyone.
Good
Good afternoon. Nice to meeting you. And welcome with all respect to the Honorable Director of Universitas Unggul, Mr. Dr. Insinyur Arif Kusuma Amang Praja, MBA IPU. Good afternoon, Bapak.
Good afternoon.
The Honorable Dean of Engineering Faculty, Mr. Rusfian Syah Rasjidin, PhD. Good afternoon, Bapak.
Good afternoon, Elianda and everyone.
The Honorable Director of International Office as well as the Director of International Campus, Mrs. Prita Suyudi SHMKN. Good afternoon, Ibu.
Good afternoon, Lianda. Thank you very much, Pak Rektor, professors. It's a pleasure.
The Honorable Vice Dean, Head Study Program, lecturers, and students from Universitas Unggul, and also the lecturer from our university partners, Bapak. Di sini ada Dr. Marliana. Thank you for joining this international webinar, Dr. Marliana from UITM, and welcome to all participants of the international webinar, Becoming an Engineer. And ladies and gentlemen, before we start this webinar, let me inform you our agenda. The first is opening by MC, and the second is opening speech by Dean of Engineering Faculty, Mr. Rusfian Syah Rasjidin, PhD. The third is opening remarks by Director of International Office, Ibu Prita Suyudi. And the fourth is keynote speech by Rector of Universitas Unggul, Dr. Insinyur Arif Kusuma Amang Praja, MBA IPU. The fifth is our main event, webinar Becoming an Engineer and discussion. And the sixth is closing. Now we will begin our international webinar with opening speech from the Dean of Engineering Faculty. We invite Mr. Rusfian Syah Rasjidin, PhD, to give the speech. Time is yours, Bapak.
Yeah. Thank you, Lianda. Bismillahirrahmanirrahim. Distinguished speakers, Professor Dr. Jamalun Laili Abdullah, Dean of Architecture, Planning and Surveying, University Technology Mara, Malaysia, Professor Heiki Kosuke, Department of Earth and Planetary Sciences, Earth and Planetary Dynamics, Hokkaido University, Japan, Chain and Project Management Center, University of Punjab, Lahore, Pakistan, Dr. Insinyur Arif Kusuma Amang Praja, MBA IPU, Rector of Unggul University, Indonesia, Ms. Prita Suyudi, SHMKN, Director of International Office, Unggul University, Indonesia, Ms. Dayude Ariesta Kiranasari, STMSC, Head of Urban and Regional Planning Study Program, Faculty of Engineering, Unggul University, all lecturers, colleges, students, and participants. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Waalaikumsalam warahmatullahi.
On behalf of Engineering Faculty at Unggul University, I'd like to warmly welcome all the distinguished speakers and participants of this seminar. Ladies and gentlemen, and all participants, this international webinar is held in order to firstly, Engineering Month activities at Unggul University. Secondly, implementation of curriculum cooperation grants for independent learning, independent campus at Urban and Regional Planning Study Program, Faculty of Engineering at Unggul University. And thirdly, implementation of the MOU, Memorandum of Understanding, between Unggul University and its partner university, in this case, University Technology Mara, Malaysia, Hokkaido University, Japan, and University of the Punjab, Lahore, Pakistan. The theme of our engineering month is becoming an engineer 3, which is the third event after two consecutive events 2 years ago. Through this event, it is hoped that students in engineering and prospective students in engineering can thoroughly understand this field, its prospects and roles. Ladies and gentlemen, and all distinguished participants, since early 2020, the Ministry of Education and Culture Indonesia has launched a new approach to learning in higher education, independent learning, independent campus, usually called Merdeka Belajar, Kampus Merdeka, MBKM. One of the programs in this approach is to provide higher education students the right to voluntarily participate in learning for a maximum 3 semesters outside their study program, whether it is within institution and outside institution, both in higher education institution and non-higher education institution, domestically or overseas. To facilitate the implementation of this approach, it is necessary to adjust the curriculum of the study program through adjustments of the graduate profile, learning outcomes, curriculum structure and course distribution, learning path options, and also learning recognitions. I believe that the experience, knowledge, information, and vision that will be conveyed by the speakers who are also part of the stakeholders will be important input for evaluation of our study program and faculty. In addition, the international cooperation that is built and implemented is also part of our efforts to achieve the vision of our university, faculty, and also study program. I'm confident that with partners, together with partners, this international cooperation will lead us to quality and relevant education, research, and also community service. In this occasion, I also would like to thank all parties involved in the implementation of this event, including Ms. Prita, the director of International Office at Unggul University, Ms. Laili Fujiwati, the Vice Dean of Engineering Faculty, Ms. Dayu, the Department Head of Urban and Regional Planning, and also the faculty students organizations, especially to the speakers, our distinguished speakers. Your knowledge sharing is very much appreciated. I wish you all a very successful webinar. Thank you. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Rusfiansyah. Terima kasih, Pak Dekan. Henceforth, we invite Mrs. Prita Sudi, SHMKN, Director of International Office, to give the opening remarks. Time is yours, Ibu.
Thank you, Leanda. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, especially the distinguished speakers and also distinguished Rector of Esa Unggul University, Dr. Insinyur Arif Kusuma Mongpraja MBA IPU, who is an engineer himself, and the Dean Rusfiansyah Rashidin PhD, Professor Jamalun Laili Abdullah, Professor Heki Kosuke, welcome, and Dr. Muhammad Shafiq. Welcome to this platform of seminar. I know that this is not the ideal way to conduct or to convene in a seminar, but we have to be grateful that nevertheless, amidst this pandemic, we are able to gather here and to still share information among each other in this national seminar titled Becoming an Engineer 3. So I'm very pleased to be here. My name is Prita. I am the Director of International Campus for Esa Unggul University, as well as the Director for International Offices. So the International Office oversees international cooperation that holds many programs, including like this one, for example, an international seminar. And it is our pleasure that we facilitate this seminar in this afternoon. And there are actually two things that I'm very grateful of this afternoon. The first one is that I get to address and welcome wonderful speakers and participants to this Becoming an Engineer 3, which means probably this has been held for the third time. So that's first and foremost what I'm grateful of, because I know cooperation is very important, that no man is an island, and therefore cooperation is a must. No problem can be solved alone, but no problem that cannot be solved together. So big or small, virtual or non-virtual, cooperation, moreover international, is a very important measure for us to solve the problems of the world. And that's the first thing I'm grateful of this afternoon. Again, I would like to reiterate that. And the second thing is, in addition to being able to greet these engineers, a room full of engineers this afternoon, I'm also grateful that I get to greet everyone who is here, especially to the profession engineer. By definition, I think engineer is a person who designs, who build, and who maintain machine, engine, building. So it is something integrated within this field, within this profession. And I think it is the only profession in the world where failure is part of their journey. Failure is part of what they encounter, what you encounter as engineer every day, because failure is one of the things that you evaluate as an engineer to build better, to design better, and then to maintain the machine, the building, and whatnot better. So I envy you all because of that. It is also a profession or a field that felt so distant to me previously. But now, as the world is merging into one, We see that cooperation is a must, it is inevitable, but also the merging of professions, the merging of field. I myself is home-based in the Faculty of Law in Unggul University, so I teach at the Faculty of Law, and it is an acknowledgement nowadays that even the lawyers need to work with engineers. Even the lawyers, when we're thinking of making smart contract, digital maps of the city, for example, digital map for land titles, for example, we have to work together with engineers. So this merging cooperation and this merging aspects in the world is something that probably we've never seen before in the past decades or even centuries. So I'm grateful for that. And it's such a pity that by statistic, the number of engineer graduates in Indonesia among all other graduates is only 14%. And data shows that Indonesia is lacking 280,000 engineer graduate for the future 5 years, for the next 5 years. And out of all the graduates from engineering study, probably only half of them, according to statistic, that or who occupies engineering job. So this is something that that needs to be paid attention to. And I do hope that through this seminar, we can disseminate how important engineering is. So with that, I wish you good luck in the discussion, and may you have a fruitful discussion or seminar. Thank you very much. I hand the floor back to Lianda.
Thank you very much, Ibu Prita. And the next agenda is keynote speech by the Rector of Universitas Unggul. We invite Mr. Dr. Insinyur Arif Kusuma Amung Praja, MBA IPU, to give the keynote speech. Time is yours, Bapak.
Thank you, Lianda, for your time and opportunity. Honorable speakers of this webinar, Professor Dr. Jamalun Laili Abdullah from University Teknologi Mara of Malaysia, and Professor Heki Kosuke from Hokkaido University, Japan, and also Dr. Muhammad Safiq, University of Punjab, Lahore, Pakistan, and my dear colleagues from Universitas Unggul, Pak Rusfian Sarasidin, Bu Prita Suyudi, Ibu Dayu, and then the distinguished participant, dear students, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good evening for all of you, and greet from Jakarta. First of all, on behalf of Universitas Unggul, I'm very pleased to welcome all of you to this international webinar conducted by Faculty of Engineering, Universitas Unggul, with the theme of Becoming Engineer 3. And also, I would like to express my appreciation to each of you for having accepted our invitation. And we are indeed very fortunate to be able to bring such a distinguished body of experts to discuss subject importance to this event. Ladies and gentlemen, as we all know that the role of engineer is very vital and fundamental in building our society. One of the functions of engineers in general is to be a bridge between the society and everything that is needed in that society. According to ABET, or Accreditation Board from Engineering and Technology, engineer is a profession in which a knowledge of the mathematical and natural science gained by study, experience, and practice is applied with judgment to develop ways to utilize economically the material and forces of nature for the benefit of mankind. So that by that definition, we realize that an engineer is a person who, in carrying out his profession, uses mathematical knowledge and natural knowledge obtained from education and also experience and also training throughout his life, and to economically transform and develop a material and energy and various natural resources into other products for the benefit of welfare, comfort, human health, and safety. And in addition, an engineering is not only required to master the sciences, but also an engineer must also be creative in using these sciences for the benefit of the mankind. So that engineers have a role to use a knowledge that has been discovered by a scientist and apply it to the problem. Engineer cannot choose a problem that they are interested in solving. They must solve all the problems that are exist, and solution must be met the criteria of what are needed, and the solution they provide must be as simple and as effective as possible. The main role of engineer is a problem solver. Engineer play a role in various problem solving activities in the world. Sometimes they solve a problem without knowing much about the theory. An engineer also an environmental caretaker. Engineering has a dual role as an environmental agent and also to creating an invention. Engineering also play a role in preserving the environment. That's it. Ladies and gentlemen, engineers also have a role in economic transformer. The task of an engineer is not easy, especially in developing country like Indonesia. The role of engineer graduates in success development is very important because engineering science is the foundation of the country development. But unfortunately, the number of engineering graduates, like mentioned previously before by Bu Prita, the engineering graduate and engineering in Asia is still very minimal. Without an engineering, a country cannot cultivate its natural wealth to the fullest. So an engineering has various responsibilities, both in development of science and technology, and also in social order of social needs. Because actually an engineering engineer come from the community as well as in practice. Engineering must be able to bridge the scientific between the needs of the community and the knowledge that they are that have been discovered. And the engineer changed in this through an activity called engineering, because essentially an engineering is a person who performs activities related to engineering. Ladies and gentlemen, finally, I want to remind all of us that as an historian once said, that engineers have to answer the calling of our home country, that we have to make people in our country prosper, and we have to create a happy society, create a better world, and become an agent of progress of human civilization. We realize that the work of engineer throughout the history have brought us to the best time to live in this world like today. Science, engineering, and technology has provided us various convenience that even the richest and the most powerful king, emperors, queens, or noble in the past century could not afford. Ladies and gentlemen, in closing, I have no doubt that by the end of this webinar, we will once again have demonstrated the value of meeting together. And let's hope that to maintain the momentum of this conference now and also in the future. And also it is hoped that this initiative will continue to enhance and strengthen the recent global trust in strengthening the network between universities, industry, and government. At last but not least, I would like to express my appreciation to the committee of this webinar. And also, once again, I would like to express my appreciation to the speaker, all of the speakers who attended this seminar. I wish the webinar all success and to you all a pleasant time in right now. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Rektor. Ladies and gentlemen, let's keep on the next agenda, our main event of international webinar. Before we start the main event, let me introduce our moderator. Our moderator is Mrs. Dayu Aresta Kirana, ST MSc. She is the head of Urban and Regional Planning Study Program of Engineering Faculty, Universitas Unggul. She finished her master degree at University of Groningen, Netherlands, in Environment and Infrastructure major. And Mrs. Dayu, please guide the international webinar. Time is yours.
Thank you for the opportunity, Ms. Lianda. And thank you, I would like to say to our rector, Bapak Arif Kusuma, and our dean, Bapak Rusfian Syah, and vice dean, Ibu Laili, and my colleague in the Faculty of Engineering, and also Ibu Prita Siyuti as our international director. All right. Okay, good afternoon, ladies and gentlemen. Good afternoon also, I would like to say to our greatest speakers today, Professor Jamalun Laili. Good afternoon, Professor. It's very pleasure for us to meet you here in this webinar. And also Professor Heiki. Good afternoon. It's very nice to meet you. And also Dr. Muhammad Safiq. Thank you for attending this webinar. All right. Before we start our webinar today, I would like to let you know about our speakers today. First, I would like to introduce you with Professor Jamalun Laili Abdullah. He is now Dean of Faculty of Architecture, Planning and Surveying in University Technology Mara, Malaysia. His research interest or expertise are urban and regional planning, economic development, and social planning. He earned all his degrees in United States of America and his doctoral degree in city and regional planning, Cornell University, New York, United States of America. And our second speaker would be Professor Heiki. Professor Kosuke Heiki, he is a professor from the Department of Earth and Planet Science, Faculty of Science, Hokkaido University, Japan. And he has research interest on space geodetic techniques for various disciplines in Earth and planetary, and GNSS positioning for slow deformation of the Earth and sensing of upper atmosphere with GNSS. And our third speaker is Dr. Muhammad Safiq. He is now a director of Supply Chain and Project Management Center at University of the Punjab, Lahore, Pakistan. And his research interests are in supply chain management, operation research, project management, data science, and so on. It would be very long if I read all of the CV of our speakers today. So, and Dr. Safiq has earned his doctoral degree from Industrial and Manufacturing Engineering at Asian Institute of Technology, Thailand. All right. With that marvelous profile of our speakers today, it will be an interesting topic, I suppose, that we will have in this afternoon webinar. So without further ado, maybe I would have the floor for the Professor Jamalun Laili to present his materials. Who will? Okay. All right. So sorry for all these speakers. You have 20 minutes to present your materials today. So yes, time is yours, Professor Jamalun Laili.
Okay, thank you very much, our host moderator this afternoon, Mr. Yuariesta. And so, first of all, Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon from Shah Alam, Malaysia, especially to Universitas Unggul, Rector, Bapak Arif Kusuma, and also the Dean, Bapak Rosfian Shah. I hope I pronounced correctly this time, and also Ibu Prita Syedi, and also all these lecturers from Universitas Unggul, as well as the students, and also the fellow presenters today, Professor Heki Kosuke, and also Dr. Muhammad Shafiq. Okay. And I'm honored to be invited by Universitas Unggul to give a presentation today. So actually, it's the second presentation. This morning, I had a presentation during got invitation from Scholar Business and Management at ITB. Okay, there was a conference on collaborations in the new normal. Okay, it's a 3-day conference, and so perhaps this is one of during this COVID-19 year, one of the positive things that we can take from here is that we are able to do a lot more of collaborations, albeit virtually. Okay, like this week, 2 days ago, presented a paper, IGU, International Geographical Union, in Romania, virtually, and this morning in Bandung, and this afternoon in Jakarta. So, so able to share a lot, and so with other people like. Here we have speaker from Japan as well as Pakistan. And congratulations again to ESA Unggul. So we have the speakers like from the 3 corners of Asia, Northeast Asia from Japan, Southeast Asia from Malaysia, and then West Asia from Pakistan. And also the areas also cover, like I'm from urban planning, and then we have like earth planetary sciences, and then supply chain, which is really truly multidisciplinary. And the topic given to me was on the city's resilience strategy facing COVID-19. So I try like to cover this within the 20 minutes allocated to me. It's quite a lot of slides, but don't worry, I can go very fast on the slide with this one. Yeah. So so my topic are related to that, the city's resilience strategy here. I'm looking at the cities and pandemic. Perhaps I'm focusing more lessons for Malaysia here, specifically focus on that. And I'd like to thank my colleague, Dr. Maliana Aziati Mazuki, who is the head of Department of Town Planning. She's the one like helped me to do all this PowerPoints, but it's like considered as a joint presentation for both of us. And just like to let everybody know that I think in our system, because I see like most of the and in Indonesia, it's like urban planning is part of the engineering faculty, and I think that that's the same as in Japan. But in Malaysia, like urban planning architecture is like a separate faculty from engineering. So we are in the what called as the built environment faculty. I think maybe we follow more towards maybe the UK and the American system, where this is like separate built environment. Whereas in Indonesia, in Japan, so urban planning tend to be under the engineering faculty. Okay, so next, Dr. Malena. So Dr. Malena, who's sharing this one? Is it from ESA Unggul or Dr. Malena? Okay, thank you.
ESA Unggul.
Oh, ESA Unggul. Okay, thank you very much. Sorry, because my slide, what I found out is when I played it, it's like there's an overlap of the words, things like that, because of like kind of maybe different, my software is perhaps outdated. Okay, thank you. So I'd like to share a bit about UiTM. We are the largest university in Malaysia, 189,000 students, and almost 500 programs, and 26 faculties, and we are found in 35 campuses throughout Malaysia. Okay, next. Our staff is almost 18,000. Okay, so these are the main campuses among the 35 campuses. Okay, so we have campuses in every state, and then certain states we have 3 campuses. So these are the main ones. So of course, Main one would be the headquarters in Shah Alam, where I'm currently at, and then so all the way up from the top until from the north to the south, and then from the east to the west. So it's going to be, I'm happy like we are signing MOU with ESA Unggul, because like when there's a student collaborations later on, when after COVID is over, then we can travel, then it's a way that the students from ESA Unggul, they come, then it's not just in Shah Alam, can take to any of our campuses in Malaysia, among the 35 campuses. So that perhaps also maybe if Professor Heki Kosuke or also Dr. Shafiq is very interested on that, then that is also opportunity for further collaborations. Next. Okay, so the faculty mentioned to you that for this Faculty of Architecture, Planning, Surveying, in other universities it's called Built Environment, but we tend to be traditional architecture, planning, surveying, but these are the three main disciplines when we started this faculty. And so we have graduated more than 70,000 students. Our current students is 15,000. And then 31 programs under the faculty, and currently we are in the top 200 in the architecture built environment under the QS World University Ranking by subject. Next. And our faculties are found in 5 campuses. So the main one being Selangor, in Shah Alam and Puncak Alam, and then we have also another big one in Perak, and then up north in Perlis, next to the Thai border, and then the 5th one is in Samarahan in Sarawak. So those are the programs in those campuses. Next. Okay, and so this is we have the Southeast Asia Built Environment Research Center. So this is a research center more on the research of this one here. So we just launched it about 2 years ago. So those are the research interest group under our center here. Next. So this is the research interest group under the center. So Kutai there is more on the traditional architecture, okay. And then we have on the green city, and then so well-being research group, tropical building performance, environment behavior, okay, disaster mitigation. So basically we have like more than 10 areas of interest. As I mentioned just now, we are the most comprehensive built environment faculty in Malaysia. We have more than 10 departments. So we have a lot of research interest. So I'm inviting like those from ESA Unggul, I'd like to collaborate to do research in all of these research areas. And then what we try to do is that, so this is, when I studied at Cornell and in the US, there's quite a number of the Southeast Asia Research Center, but they tend to focus more on politics or in economics. So for the built environment, it's difficult to find one, so we set this one up to become kind of a center for the Southeast Asia built environment. Next. Okay, so now I go into the presentation today, and we know the world's population 7.7 billion. Next. Okay, and of those, we are officially an urban country, and then we know that if you look at the history, the most developed countries are considered as the urban countries. Okay, so like we can see like around the world, those countries which are the most developed, has highest economic development, are also the so-called urban countries. So like the United States, okay, the UK, okay, Germany, okay, Japan, okay, and even in Asia, Southeast Asia, especially like Singapore, the most developed, economically advanced, they are like the urban country. Okay, so now we are in the now the planet Earth is called like urban planet Earth, because now more than half of the people live in urban areas, and Malaysia officially became an urban country in 1991, okay, when we started to move into manufacturing. Next. So go into Malaysia. Kuala Lumpur as the capital. So Malaysia has a population of 32 million. Of course, this number is not big compared to Indonesia. I think Indonesia now has about 270 million. So such a huge country, I think the 4th largest in the world. Okay, so capital city in Kuala Lumpur. Next. Okay, so when we look at urbanization in East Asia, Malaysia is considered among the most urbanized countries in East Asia. Of course, in Southeast Asia, we are second behind Singapore. But the countries like Indonesia also is urbanizing very rapidly as well. And then, by the year, I mean, as I mentioned just now, we became urban country in 91. Okay. And now, it's like 30 years later, 77% of the people in Malaysia are considered as urbanites. They live in urban areas, and the percentage in rural area is only 22%. So that's why I think this is related to economics as well. The urban area, if you have most of the people living in urban areas, then they tend to be more developed compared to the rural countries for two main reasons. One is that we learn in economics the elasticity of demand. That means that if your income increase, okay, like from maybe $1,000 income to 10,000 and after that $20,000, what happens is that you will spend a greater proportion of your income on tertiary and secondary sectors, okay, services, as well as manufacturing. Okay, buying cars, buying houses, and you have more money, then you go for vacations, high-end vacation, and then you invest in the stock market, things like that. So this, and then the primary ones, like agriculture. Okay, you spend more on food, but percentage-wise, most of your money will go for the secondary and tertiary. So secondary, tertiary, there are most of them located in urban areas. Okay, so that's why you see there's a correlation of the elasticity of demand among the different sectors, and then with urbanization. And that's why, like in the 70s, the government really encouraged, especially the Malays, to move into urban areas. I remember, like if you go to Kuala Lumpur, there was a place called Bandar Tun Razak. It used to be called Kampung Kongo. The reason because in the 60s, the government sent our army to Congo as part of the United Nations Peace Corps. Okay? And then when they returned back to Malaysia, the government told them, okay, don't go back to your villages, stay in the city in Kuala Lumpur, you open up the land. So they open up the land and they call it Kampung Kongo. Of course, now it's become very much an urban area. Now it's called Bandar Tun Razak, which is like only like 10 kilometers from city center of Kuala Lumpur. Okay, so urbanization really play a big role in economic development of nations. Next. Okay, showing the location, there's Kuala Lumpur, metropolitan Kuala Lumpur. So the city of Kuala Lumpur, the city itself, it cannot expand the boundary because it's surrounded by the state of Selangor, because Kuala Lumpur is part of federal territory. The rest outside it is part of the state of Selangor. So it cannot expand. So its population about 1.8 million, but the whole metropolitan of Kuala Lumpur has population about 6.5 million. Of course, compared to Jakarta and Tokyo, it's much smaller. Okay, and even compared to Lahore, is smaller. Okay, but that's where the situation now. Next. Okay, and so this is area, the district within Kuala Lumpur. Next. Okay, so in the metropolitan, we have the Kuala Lumpur City Hall for the Federal Territory, and then Petaling Jaya City Council, Subang Jaya, Shah Alam. So our university is located in Shah Alam, which is a city about 20 kilometers outside of Kuala Lumpur, and is the capital of the state of Selangor. Okay, so and Putrajaya also federal territory. So this is basically the whole metropolitan of Kuala Lumpur. And then so Putrajaya is administrative center for Malaysia. Okay, we developed that under Tun Mahathir about 30 years ago, and I think Indonesia is going to have your new capital in Kalimantan. Okay. Next. Okay, so to the main topic, so that is like kind of introduction on that, on the pandemic. Okay, COVID-19. So pandemic how will shape the city. So basically, and another reason why the city keep expanding and then the country become developed with the cities is that because another important part of the city, this is where the ideas merge in the city. So through the density, through the multidisciplinary actions, activities there, then we start to create a society where new ideas start to flourish. And that's why it's very important really for us to really look at the city and how we can develop the cities to support the economic development of the nation. So with COVID-19, most of the cases are in the cities because most of the population now live in the cities. So this is opportunity for us to respond, recover, and build long-term resilience. Next. Okay, the statistics worldwide, more than 200 million were affected by COVID-19. And in Malaysia, now it's like almost, this is as of 8 August. So now we have about 1.3 million people affected in Malaysia. So with the population of 32 million, so that's about 5% of the population of Malaysia has been affected by COVID-19. And then the number of deaths also have been going up very, very high. Yesterday was 320. So a few days before that, 360. So when it started last year during the first lockdown and it first came to Malaysia in March of last year, and we are able to manage it. We are considered as one of the best countries that are able to manage COVID-19. Unfortunately, this year, what you start to see is that and Indonesia also having this problem as well, that the cases like just went very sharply starting in March of this year and has been unabated. And then now we have like the cases more than 20,000 every day. Okay. And I heard like Indonesia also, I read in the newspaper that more than 1,700 people, doctors and nurses also have died in Indonesia. So what you see is that globalization, this is like the best of globalization. COVID, I would call it maybe the worst of globalization. We started to say like it started in Wuhan, China, and then it moved to the West, to Turkey, Iran, and then to the UK and Europe, and then to the US. And then after that, shifted to India and also in South Africa. And now the hotspot is in Southeast Asia. And then we, Southeast Asian nation, Malaysia, Indonesia, Thailand are really struggling at this stage. We are praying that we are able to control it effectively. Next. Okay, so like to share, like Kuala Lumpur, like it started with that it's because of the health problem. Because like early Kuala Lumpur is actually a relatively young town, young city. I mean, it has been around for only 200 years compared to cities like Jakarta or Japan, Tokyo, Kyoto, or Pakistan. You have a long history of cities, but not in Malaysia. So Kuala Lumpur, like about 200 years old, and then during that time, the buildings made of wood, prone to fire, and also improper sanitation. So, and then there's major outbreak of cholera in late 1870s, and then flooding and fire. And then what happened was that the first urban planning at that time was more on sanitation. So I think as well as in other cities around the world, sanitation was the first thing that really triggered urban planning. The same with Kuala Lumpur. So what happened was sanitary board was created in 1890s for sanitation and upkeep of roads. That's the start of urban planning, which is the public health approach. Next. Okay, and so with that 1890s, then we start to have the first town planning committee was set up during that time. And then in 1921, so considering this year is urban planning in Malaysia is 100 years old, because we had our first town planning named Charles Reid, who's brought from Australia. That was during the colonial time under the British. And then we had the town planning legislation 2329, and then Town and Country Planning Act 172 was enacted 1976, and then Town Planners Act 1995. Okay, so that is evolution of urban planning here. Next. Okay, and so what happened here is that the city, because this is where the people are congregating, and then the very high density, so they're very much at risk of COVID-19. So many densely populated areas have experienced high number of deaths. Okay, so how do we deal with this one here? It's quite interesting. UN Habitat also have done the study throughout the world, and then whether density really relates to the COVID-19. And I think their finding was that it's not really. Is still inconclusive on that one, because there are certain cities that are able to control. Okay, case in point, Hong Kong and Singapore. Okay, it's very high density, but they're able to control that. So still, it's not that density per se, but how you manage it. So urban management is very important. But quite at the same time, also you need to be able that to see that in the city you have different groups. Okay. So when you have informal settlement, urban poor, homeless, refugees, and things like that, these are the people who may be affected disproportionately of COVID-19. So that's why maybe you see that some of the cities are able to control, maybe they're able to address all these issues of informal settlement, urban poor, and other things. Next. Okay, so in Malaysia, so we have all of this government response. Okay, we have the MCO phase 1 that was in March of last year, so we were able to control it. But now, what happened is that we had like emergency MCO, and then now we are really into the phase 4 of the MCO in Malaysia. Okay, it's very much. The lockdown is not as worse compared to last year, but last year the lockdown was very, very effective. This year, somehow it's less effective. One of the reasons is that the Delta variant is very contagious compared to the variants before this, but we are working hard on this. So what we do is we are ramping up of the vaccination. So now the vaccination rate in Malaysia is one of the fastest in the world. Every day we are able to vaccinate about 500,000 people in Malaysia. Okay, so now it's like 30% of the people in Malaysia are already fully vaccinated. So government targeting 50% by the end of this month. Next. Okay, and so the government here through research and innovation and the strategic communication. Through like telling people like to follow all the SOPs. Next. Okay. Community empowerment and incorporation. Okay, so this is, and also economic stimulus package. So the federal government come up with a few of economic stimulus package worth like tens of billions of ringgit to help counter COVID here. Next. Okay. So for the cities here, what are the priorities here? Is that one is that we have to start to rethink the form and the function of the city. We started to have the urban sprawl and spreading around to the newer area. So maybe we start to think again, like now we cannot travel far, maybe the neighborhood concept of the city need to make a comeback here. Okay, so that's one. And then another thing is that a new normal urban economy. And then we need to address systematic poverty and inequality. We start to see that if we have a lot of poverty and inequality, it will be more difficult to control this. And then in terms of clarifying urban legislation and governance. So this is like based on the UN Habitat. So now we need to be looking at this one here, how we rethink about the form and function of the cities, and then also of the poverty and inequality. Next. Okay, so rethinking about that. So really on the idea of sustainability and equitability, and then we need to look at the tools and existing tools to support the system to become healthier, and then density is not per se is negative regarding this, but then it has to be well-planned densities, so it have to be supported by other services, and also safe, affordable public transport system. And then I think like in like this morning, look at the CEO of MRT Jakarta presented a paper on the MRT Jakarta, and then look at how that is able to connect to other areas in Jakarta. Next. Okay, so infrastructure is one of the things really to deal with this one. So it's include health infrastructure and as well the infrastructure, and also basic services, water and sanitation services. Because I remember when I did my PhD at Cornell, my dissertation is on urban environmental health, and then so using Penang as a case study, so looking at how like in Malaysia the government able to provide sanitation, safe water supply, and then as well as good sewerage system, and is able to control waterborne diseases. So that is something that we need to look at on that, and then need to focus and mention on slum and informal settlement, and then investment strategies for affordable housing. Next. Okay, I have to go fast on this one here. So another thing is on the social group. Okay, because in urban areas we have various communities, various groups, so we need to look at the social assessment and also look at the economic structure of that, how to support the population, and also of the political governance to lead on this. Next. Okay, so this is like urban legislation. Okay, cooperative approach. Okay, resilience and preparedness. We need to be resilient when dealing with this one, and then transparency and participation. Now with the social media, we have to be very transparent on all those things. Okay, especially now a big debate on ivermectin. Okay, so and then also the recovery on that. Next. Okay. SDG next. Okay, so we know about the SDGs here. Unit number 11, sustainable cities and communities as well directly related to cities. Next. Okay, next. Okay. So the new urban agenda here really on one the cities, which is well planned, design, finance, develop, governance, and of course now the main with the COVID here, the focus is back into what they call as the healthy city. Okay, and related to the smart city. Next. Okay, and local next. Okay, so Malaysian Urban Forum. So this is like okay, all invited. On this one, we're going to have the third session this year. Next. Okay, so development control of Kuala Lumpur structure plan. Next. Okay, so we need also development control. Really, maybe this is something how we're going to deal with the COVID-19 here, because we found that if it's like formal settlement is easier to control compared to informal settlement or slums. Next. Okay, way forward. Okay, so this consideration regarding COVID-19 here. So this is like in a nutshell. Okay, multi-sectoral. Okay, whole of government and society collaboration. Good mental well-being. So mental now in the city, there's a new like kind of a big crisis as well, is the mental health. It's not just physical health, but because when people are locked down, then also on mental health. So we need to mobilize additional resources. Okay, and then communication of information. Okay, preparedness, essential services, and also vulnerability. Okay, and also on the informal sector now with the Grab and Indonesia Gojek and things like that. Next. Okay, so the conclusion is that we can use that this COVID pandemic here as an opportunity for us to rethink about urban space. Okay, so we started with the health, but also about the ecology, and then also with COVID here about the health, about the ecology, about infrastructure, and also about the social and economic as well. So now it's become more multidisciplinary, more inclusive on that. Okay, next. Okay, with that, I thank you for your time, and my apology, I'm taking a bit more time than allocated. Thank you very much for your attention. Okay, I pass it to the host.
All right, thanks a lot, Prof. Chamalun. It's all right with that wonderful presentation. It's okay for just exceeded 5 or 10 minutes. Okay. From Professor Chamalun presentation, we can take some takeaways like, yes, of course, outbreaks and or natural disaster is indeed usually become a turning point for a city to deliver a better city planning, because it's not only in Kuala Lumpur, but some years ago, some centuries ago, that when flu outbreaks happen in European city, they also changed a lot of their city planning. They built more health facilities and change some their infrastructure in cities to make a better living for their people. So yes, it is. Outbreak is also not beneficial in our today's life, but it will make a better living if we can get a lesson from that. And also, we need a more multidisciplinary knowledge to solve our next challenges, future challenges, to make a better living for people. Thank you, Professor Chamalun, for your insightful presentation. And also for the participants, maybe you can head to the chat box if you like to give some question for our speakers here, or maybe just give raise hand in question and answer time later on. All right, now maybe I will head to Professor Heikki. Are you ready with your presentation? You will present yourself?
Yes.
All right. Okay.
Can you see the screen?
Yes. Very
I will
clear.
start the slideshow. Okay, thank you very much. The first talk is about COVID-19, very timely topic. And the second talk is about the natural disaster, for example, earthquakes and volcanic eruptions and tropical cyclones. And the GNSS are included in the title of the talk, means the Global Navigation Satellite System, just like GPS, which is very famous. Okay. And I am a geodesist, and I'm doing geodesy. Geodesy is a kind of earth science to study the shape and dynamics of the earth and how to get the information on the position on the earth. And this is the title of my publications this year and last year. And with geodesy, I study, say, solid earth and upper atmosphere and water vapor, gravity, and many different things. And I wrote many papers with my Indonesian colleagues. They are mostly my students and who studied in my university. They are the people with red. And because Indonesia, you have similar natural disasters such as earthquakes and tsunami that we have also in Japan. So we have the same interest. So space geodesy. So what is space geodesy? A brief explanation. And this is a map of the Japanese islands before geodesy. And this is a map of Japan drawn after geodesy about 200 years ago. And with space geodesy, this is very accurate. And you can see the change in the position of these points. And in this figure, I show the movement of the crust surface of the Earth before and after the Tohoku earthquake in 2011, March 11th. And this is a world version of the map before geodesy. So this is not accurate. However, with geodesy, we can make a very accurate map. And with space geodesy, for example, you can see the movement of the ground. Here, the yellow curves are the boundary between tectonic plates, and the plate move with each other. And we can measure such movement using space geodesy. I started my career as geodesist by working on VLBI. This is a kind of technique for space geodesy using the huge radio telescope like this. It is in 1980s. And my first job was to measure the movement of the Pacific plate relative to the Japanese islands. So this is a classical technique, and this is antenna I used many years ago. And this is the result. For example, this is a station in Hawaii, and this is a station in Marshall Islands. They are both on the Pacific plate, so same plate. So they do not move with respect to each other. So the distance between them is the same. However, these Pacific plate is moving northwestward by about 8 centimeters per year. So the distance between Japan and a station of the Pacific plate is getting shorter and shorter every day. And this is the results in 1984 and 1985. It is 35 years ago. And now we have a better or cheaper tools called Global Navigation Satellite System, or GNSS. So it is GPS and GLONASS and Galileo and many others. So we change the natural radio source to artificial satellites. And now you see the advance of the technology in tens of years. And this is showing the Pacific plate motion from 1997 to 2019. And this is a movement. And this is composed of a daily determination of the positions. So this is very different from what we had in 1980s. And if I enlarge a certain part in 2018, you can see that this is actually made of small dots, and one dot corresponds to one day. So we determine the position every day, and it changes in time. So now we have a cheap ground facility for measuring the movement of the ground. And here at the top of this pillar, we have an antenna to receive signals from satellites. Because it's cheap, it increased very much in Japan. Now we have about 1,300 such stations deployed all over the country. So we can monitor the movement of the ground every day like this. And this is called GeoNet, which means GNSS, Earth Observation Network. So it started operation 27 years ago, 1994, and it can track GPS and Galileo and GLONASS and QZSS and so on. And it's made of 1,300 continuously tracking stations. And raw data and solutions are available to public online. Okay, so this is the first results published in 1995. This is a coast-seismic deformation. So comparing the position before and after a large earthquake. And that earthquake occurred here is with magnitude of 8.1. So this is a very large earthquake. And the stations moved eastward. So this is 10 centimeter. And in the time series, you can see 3 components, east-west, north-south, and up-down. And on the day of the earthquake, they experienced a sudden jump. They changed the position by, in this case, 43 centimeter. And at that time, we had these stations. It is only about 100. at the time of 1994. But now we have 1,300 stations. So it expanded in 27 years. And this is, I'm showing a frontier. So what is new about GeoNet? So this is showing the kinematic solution. I'm showing the position change in every second before and after the Tohoku earthquake 10 years ago, March 11. So this is the epicenter. The station starting to move. And the color means upward displacement. So the red is uplift and blue is subsidence. So you can see that both horizontal movement and vertical movement. Okay, and this is another example. This is the largest aftershock of that earthquake. Again, 1 second data. So this is the epicenter, earthquake occurred. And shortly after that, the station starts to move. And this information is very useful to study this earthquake. For example, the position and size of the fault and the seismic waves propagating and so on. So this is now a very important infrastructure for earth science in Japan. Okay, so this is another frontier. So far, we could measure the position of the stations only on land and never in the seafloor. But the new technologies are making it possible. So if microwaves could penetrate seawater, we could put GNSS receivers on the seafloor, but this is impossible because microwave cannot penetrate the seawater. So instead, we use acoustic wave between something floating on the ocean and the ocean floor. And we determine the position of this buoy using GNSS, using the microwave from satellite, and we determine the position between this buoy and seafloor benchmarks using acoustic waves. And this is a movement of the crust by the Tohoku Oki earthquake in 2011, but this includes a few submarine stations like this, 1, 2, 3, 4, 5. They moved tens of meters by this earthquake. And we also have several stations in the off the Pacific coast of southwestern Japan. And in addition to the velocity of the stations on land, we can see the velocities of the stations on the seafloor. Okay, this is another technique called interferometric size synthetic aperture radar. Now we can make a two-dimensional map of post-seismic displacement by using this technique. So this is an antenna, this transmit microwave, and it reflects and come back to the satellite. So it works like this. So this is a certain place in Kyushu, Western Japan. There was a large earthquake, and there's a fault movement like this. And what we do is transmit signal and receive the signal and measure the distance between the satellite and this small part of the ground. And we do the same after the earthquake. And we can tell the change. And we give a certain color to this pixel. So this color indicates the phase difference. So this is just like we have so many millions of GNSS stations on the ground. So we can draw a very detailed map of cluster deformation. This is an example for the 2016 Kumamoto earthquake. So you can see the two-dimensional distribution of displacement. And we also have GNSS stations, but you can see this is not dense enough. With only GNSS stations, it is difficult to tell the size of the fold and how much they slipped by this earthquake. Okay, so GNSS is very good in temporal density, and INSA is very good in spatial density. So we need both of them, and they are both very useful to study earthquakes. And GNSS, we can measure the cluster movement, of course. However, we can also measure different things, for example, water vapor and total electron content in the upper atmosphere. So it has many functions. So there are water vapor, the troposphere, and there are many free electrons in the ionosphere. So GNSS can measure these quantities by measuring the delay of the microwave signal. So non-dispersive delay is water vapor, and dispersive delay is ionospheric delay. So we can distinguish these two. And they are also very useful for earth science. And this is a Japanese system of positioning satellite called QZSS, in addition to GPS and GLONASS and Galileo and Beidou. So it has one geostationary orbit satellite. So it stops relative to the Earth. And we also have 3 quasi-zenith orbit satellites. So its trajectory is like this. So what is important is that we see one of the 3 satellites every time at the zenith, at the top of the sky. So we can see, so it is not bothered by high buildings. So this is very useful in urban area. And by using this, we can see, for example, phenomena in ionosphere. So this is what we call medium scale traveling ionospheric disturbance. This is very everyday phenomena, but this is a very beautiful example of observing such disturbances. And also we can count how much water vapor we have above Japan. So this is something similar to a radio sound used by meteorologists, but this is done only twice a day. However, with GNSS, we can continuously measure the amount of tropospheric water vapor. So this is very useful. For example, this is a very bad typhoon in 2019. So this is a very big one and attacked Japan. And it caused flood. And we can measure, okay, so this is a distribution of waterfall. So it is 30 gigaton water precipitation in one day. So this is really amazing. And we can compare the distribution of rain and distribution of water vapor. So they coincide with each other. And typhoon landed onto Japan. and we can compare the large amount of water vapor where there's hard rain is going on, and the typhoon is leaving, and the rain area and water vapor area is also going out of the country. And we can even measure how much water vapor exists in the sky during this typhoon passage. Okay, and this is the last topic. And typhoon brings a lot of water. It works as a road and depress the ground. And we can measure this also using GNSS. Okay, so this is a typhoon passage, and this is a rain area. And we pick up stations in the non-flooded area with green, and flooded area with blue, and compare the behavior. Here is the non-flooded stations. And this is a daily up position over 1 month. And this is a typhoon day. And there's nothing particular. They didn't change its position. However, if we see these flooded region stations, we can see cluster subsidence. So the ground went down, subsided by 1 or 2 centimeters on the day of the typhoon. And it recovered in 1 day because Japan is a small country and water is drained to sea in 1 day. Okay, so I talked about a dense GNSS array in Japan, and it is a useful infrastructure to study cluster deformation and ionosphere and tropospheric water vapor. And I showed some examples of Tohoku earthquake and 2019 large typhoon. And I also talked about other techniques such as VLBI and INSAR, which let us know the 2-dimensional distribution of deformation, and GNSS acoustic technique to measure the movement of the ocean floor. Okay, I think this is the end, and thank you for your attention.
All right. Thank you, Prof. Heki, for, again, very insightful presentation. Yeah, it is a very technical, I understand. But one thing that I maybe can get some point from Professor Heki studies or research is Professor Heki make us to so from that study we will get some information on trend of how earthquake or other natural disaster reshape our earth in a different level. From the typhoon in Japan in 2019, it changed the land subsidence. It makes land subsidence in Japan afterwards. And also from the earthquake, we know that it's changed our land in Japan after all. And those information really needed to plan a better environment. So people and the city itself will be more resilient, and to reduce loss of our society, of our city or our nation. And thanks a lot for the research and study. Your study is really enlightening me, especially. Thank you, Professor Heki. And next presentation will be Dr. Muhammad Safiq. He will be presenting about IoT in industrial era in 4.0. Yeah, the time is yours, Dr. Safiq. Yeah.
Good afternoon, everyone. This is Dr. Shafiq.
Yeah, afternoon.
Can you please tell me voice? quality is clear?
Yeah, I can see your presentation very clearly.
You can listen me clearly, right?
Yeah, yeah.
Okay, thank you.
You can make it in a
This is Dr.
slideshow.
Shafi. The topic of my presentation is IoT and Industry 4. And before starting my presentation, I will start with an example of a well-known manufacturing company, mobile manufacturing company, which was established in 1865 and led the market in mobile phones. But a few years ago, the general manager of that company started crying during the interview when the question was asked, why you did fail? Why you get failed in the market? He replied, we have done nothing wrong, but we failed to make a decision of opting the technology. So this is the importance of the technology, and that company is a well known to everyone, and the name was Nokia, established in 1865, but one wrong decision that they refused Android system, and then they were washed out from the market. So today we are going to talk about technology. The director Parita talked about engineers. The definition of the engineer is design and development. But being industrial engineer, we call it, the definition of an engineer is to optimal design and development. So nowadays, because the market is very competitive, just design and development doesn't serve the purpose. We have to design in a very optimal way, because the competitiveness of the market will wash out you if you are not innovative and optimal. So let me start our topic. Internet of Things means connectivity of the devices, connectivity of the machines, and connectivity of the stakeholders in order to make an optimal decision making. Because information is the most important key in today's world. If you have all the information about your supply side, information about your demand side, then you are in a position to make an optimal decision. But if you don't have enough information, a few examples of the application applicable in healthcare, especially during the COVID-19, we have witnessed telemedicine services in various countries across the world. Like the conventional or traditional hospitals were closed during the COVID-19, but the telemedicine facilities were available. And this was only possible because of the interventions of IoT in healthcare sector. Then we have traffic control. We have smart cities concept. You don't need anymore the traffic warden or traffic police officers on the roads. You just like install the cameras on various locations of the city. And if someone violates the rule, the cameras took images, and those images, that data transmits to the central office where it was analyzed, and then a challan or a fee challan is sent to the owner of that vehicle in order to pay to the government. So there are several other applications like vehicle safety, energy, agriculture, and main manufacturing industry that I will discuss in detail in later part. Here are a few very commonly used sensors like smartwatch. Most of us use this smartwatch, Fitbit, smart glasses, ECG sensor, EEG sensor, PPG sensor, and glucose meter. Here is one example like how we use these in healthcare sector. You may see that there are various sensors on human body, like EEG sensor, ECG sensor, and several other sensors on the human body. Each sensor collects data from the human body and transmit it to the central platform or central database. Like EEG sensor collects data about brain wave, then ECG about cardiac position. All this data is transmitted to the central platform, where we use machine learning and artificial intelligence in order to analyze that data, in order to analyze the position of that human being, whether he is in good condition or he is suffering from some kind of disease. So this is a very simple and easy to understandable application of various sensors or IoT in healthcare sector. Now, the second part of our topic, Industry 4. The journey of Industry 4.0 started from Industry 1.0. And Industry 1.0 is mechanization, start of mechanization. In the earlier world, people used to develop and build the things manually. Like if I give the example of fabric, women mostly used to weave the fabric at home through needles. But then the concept of weaving loom emerged. People used to travel in the earlier age on horses, on a bull cart, but then the steam engine came into existence. This is the area of Industry 1.0, when manual system converted to mechanization, to machines. And after we transfer to the machines, then the concept of cost saving emerged. Then the people developed mass production and assembly lines in order to produce things on a larger scale, so that the cost of production can be reduced, can be minimized. After that, once we transmitted to the machines and mass production, the idea of automation came into existence, that we should automate machines, and automation done during the area of Industry 3.0. And finally, today we are on Industry 4.0, where not only the automation, few people mix Industry 3.0 with Industry 4.0. In both, automation is there, but in Industry 4.0, not only the automation, but we use big data and cyber system. We use cloud, in which the data automatically analyzed by the artificial intelligence and machine learning processes, so that we can make optimal decision even without the interference of the humans. In manufacturing industry, primarily we get data about the machines, about the production processes, about the businesses, and we remotely operate our plants. I still remember last year in 2020, we were moving from Vietnam to Pakistan, and we stayed for a few hours at Doha International Airport. One of my colleagues who was residing in US, he was controlling his workshop at the airport, and he showed me how he is transferring all kind of advices to his employees, that how to deal with the customers, what to do next, and what to do after that. So through Industry 4.0, you are enabled for a faster, flexible, reliable, and efficient processes, which reduce cost of manufacturing and ultimately high quality of your produce. Is the voice clear?
Sorry, it's a bit echoing, Dr. Sefik. It's like you have a double voices there.
No, it's clear now or not?
Yeah, it's clear, but it's like echoing, because sometimes you lost and sometimes your voice is like double.
Maybe I'm using microphone, so let me remove this one.
Yeah. We can try. Maybe you can remove your microphone. We can
no,
try.
I'm just using my laptop, so it should be clear now.
Oh, all right. Okay. Maybe just push it. It's okay. Maybe if there is another disturbance, I will tell you later.
Okay, thank you.
Yeah.
So we need to understand the technological pillars of Industry 4.0, because without understanding these pillars, we cannot implement Industry 4.0 in our system, in our industry. So these are few pillars. I will start with machine to machine. Machine to machine means the machine can coordinate and communicate with, one machine can communicate with other machine in order to transfer the data, in order to give the valuable information, so that if there is a problem in one machine, it will be communicated and the data will be communicated to the central platform where we can analyze everything. Another important thing here is like the big data. Without using this big data, we cannot optimize our decisions. Like in automation, as I discussed earlier, in Industry 3.0, we have automation concept there, but not optimal automation. In Industry 4.0, we use big data in order to make optimal decisions. So these are the technological pillars. Anyone or all of them are required in order to implement Industry 4.0 concept. Few organizations have implemented 1 or 2 or 3 technological pillars, but without the implementation of all of these pillars, an organization cannot be called like Industry 4.0 industry. So in a nutshell, if we implement IoT project in any organization, the minimum you do is the monitoring, like the monitoring of operations, monitoring of the efficiency, monitoring of the quality of the product. And if we go one step further, we can optimize our decision because we are gathering the data from the machines and from the processes of that organization. And after analyzing that data through machine learning or artificial intelligence techniques, we can optimize our decisions. And at third stage, if we optimize our decision, but there are some disturbance in the operations or in some machine, we can control that machine remotely or by manual interference. And finally, if we implement all these parameters, we can automate and we can transform our local or traditional industry to the Industry 4.0. So here are a few steps how you can collect data. We can use sensors, we can use gateways, we can use routers or media converters for data collection purposes. Then the collected data transferred to the platform, central platform, where it is analyzed through artificial intelligence or machine learning techniques. We also use cloud computing for this purpose. Here are the data presentation and storage. Once you get the results, you present the required outcomes like overall equipment efficiency, energy consumption, condition of the machines, and trends of the market or your accessibility to different supply side like the manufacturing assemblies and also to the market. Then finally, you use actuators and process improvement techniques, which is called Kaizen process, like the continuous quality improvement techniques in order to improve your industry. One more important concept is digital twinning. Digital twinning means virtual representation of a real world object. Like instead of developing a real world object, what do? You develop a virtual representation of that object. How it helps? It helps in reducing or minimizing the cost, because first you develop that virtual representation of that object. It also reduces the time and it also gives a real image to the customers, and they can comment and they can give feedback to you, and you can improve your project, your product. So it helps, as I already explained, in cost saving, enhanced productivity, and also one important importance of this concept is rapid customization, which is the next generation. You can say Industry 5.0, like automation, mass production with the concept of rapid customization, which will be the demand of the next generation of this industry journey. So if you have low cost, you are more competitive in the market. And if you are more competitive in the market and you have high quality products, your customers will be happy. And it would be easy to, through Internet of Things, to trace your goods and get feedback from the customers. By implementing all these concepts, your business will grow and you will become, sooner or later, you will become leader of the market. And why Industry 4? There is a very emerging reason. Offshore manufacturing model is challenged because of several reasons, because of cost benefit ratio, because of uncertainties in global trade, and several other factors, political issues in the economic world. And nowadays, due to emerging condition of COVID-19, many countries are closing borders for other countries. So offshore manufacturing concept is getting challenged day by day. So we need to find a solution, and that solution is Industry 4.0. And another reason is that Industry 4.0 is not only for the manufacturing or civil or construction industry, it covers all the areas of starting from business processes, supply chain, sales and marketing, maintenance, infrastructure, and everything. You can implement this strategy, this concept to all the organization and all the businesses. Few other reasons include if you implement Industry 4.0 concept, you can operate your factory, your organization even during the lockdown, because you have remote access, you have remote control to the machines, to the factory, and you can easily operate your machines and the organization. But if you don't have Industry 4.0, we have witnessed that many organizations got closed during this COVID-19 lockdown period. Another important importance of Industry 4.0 is mundane, repetitive tasks can be done by the machines, because we automate the machines and the repetitive tasks are done by the machines, and the humans are free to perform the innovative tasks, to innovate the things, to improve the things. And finally, as the labor cost is rising throughout the world, so we need to find some innovative solutions which are possible through Industry 4.0 through automation. Another important factor is in today's market, even the customers from the developing nations, from the third world countries, they are more aware due to information, due to excessive use of social media. So they are aware about the cost and quality. And in order to achieve cost and quality, you need to automate the system. You need to implement the standards for manufacturing the goods, so that your product is of high quality and at the same time with a competitive price. Also, you provide after-sales services to your customers so that they can trust you, your product, that if your product gets failed, they can get services from you. There are a few key considerations in implementing, in the journey of Industry 4.0. The first and unavoidable requirement is your all organization needs to be digital. If you are in a supply chain, all the stakeholders of the supply chain needs to be transferred to digital. Then every business organization must have key performance indicators and key result areas well defined. Because if you are ambiguous, it is okay in the manual system. But in Industry 4.0 or internet, if you implement Internet of Things concept, you need to be very specific. Your market need to be very specific and well defined. Then everyone, every organization, must be ready for continuous improvement, which we call is a Kaizen project. Then the agile methodology should be implemented phase-wise. If you try to implement at once, you may get failed in the end. But you must have proper training of the employees, that you have to implement it phase-wise to all the departments. And all departments should be on board, and this is the prerequisite for any change in the world. Then we have another concept, which is Industrial Internet of Things. And this is little bit different from the like IoT, simple IoT, because IoT covers all the areas, but industrial IoT covers, it is specific or customized for industrial purposes only. This has mainly two parts. First one is technical part, second one is non-technical part. In technical part, you check your system's readiness, you check architecture of the system, you check your like hardware, software and protocols, that whether these support the implementation of IoT or not. In non-technical part, you check your team and your organization, your vision and mission. I would like to quote here one very interesting example. Like 20 or 30 years ago, when computer came into industry, the managers, the foremen, even the workers, when they were introduced with the computer, they started using CD-ROM in order to place their teacups, which was not a proper use because they were not trained for the purpose for the use of computer. Similarly, in order to implement IoT in your industry, or in order to make your industry 4.0, you need to train your team. So non-technical part is also important along with the technical part of IoT. Here are a few like drawbacks of connectivity as well. One drawback is you need uninterrupted operations of all the devices, because if there is a disruption in any one device, in any single machine or any single sensor even, your whole system will be get disrupted. So this is one drawback you may see, and this drawback can be covered by proper maintenance and by proper checking of the system. So as we are going towards more competitive world, the markets are becoming more customer centric. You can see like first we have, as I represented product digital twinning concept, we have digital project, which is called product visioning. Then we have product sales, then actually manufacturing and assembly of that product. And finally, you like provide services to your customers for that product. Here is the comparison of traditional and future of like our industrial machine manufacturing. In traditional setup, we focus mainly on products, the development of the products, and less focus is on the services. But in future, the focus will be transferred to the services, because as the market gets competitive, you need to be innovative. You need to be very close to your customers in order to provide them all the trainings and all the after-sales services, which is possible, which is easily possible through Internet of Things. Here are a few like real-world examples. I will quickly go through because I know the time is like going up. This is a logistic for, like you develop 3D printers. 3D printers communicate with the production and then it goes to the warehouse. All the things are automatically managed through sensors. And then once the things are in the warehouse, the logistics get the signal, the truck came and the things are moved to further shipment. Here is a construction industry. According to a study, like semi-automated mason, they found out that a robot, if he build a bridge, he can put 3 bricks in the same time a human place a single brick. So they developed this system of automation. They develop a 3D geology survey, then they develop a 3D design, then simulation, then digital delivery, then they develop PCs, fabrication, then through JIT delivered, and then construction through like a robot. Instead of human, they developed this bridge through robot, and the results were 3 times, they developed in a 3 times faster manner. Like the time taken is 1/3 of the actual time if like the human masons develop this bridge. Here are a few examples of RD Smart Factory. I would play a simulation here, like how they control through sensors. This is modular montage, like modular assembly and sensors control. You may see a few lights here. These are the sensors which control the movement of this assembly. This is automated guided vehicles. And these all functions are controlled with central platform. Like you can control all these. And these are automated. Now just see that there is an obstacle until you remove that obstacle. Once you remove that obstacle, AGB then start moving again. Here is another example of laser tracking system, how you make alignments in order to reduce the errors. This is alignment made. And if you disturb the alignment, it will automatically come to alignment again. And again, the system is controlled by a central platform. Here is that platform. So here is bionic claws. Instead of manual picking and placement, you use bionic claws. And this automation is a necessity of the implementation of Internet of Things.
Sorry, Dr. Safik, that I need to remind you, you have exceeded 10 minutes.
Just,
time.
I will finish in 1 or 2 minutes.
All right, okay. Okay.
This is the last example because nowadays we are suffering from the COVID-19. And I just want to mention here, we, the engineers, mostly think that healthcare is not our sector. It's not a correct thinking. Healthcare also requires engineering implications. I will mention few in the telemedicine, my presentation with this example. And you may see how this market emerged in the US. They started treating patients remotely, and it was 2.3 billion US dollars in 2014. Then this market emerged, and it becomes 1.9 billion US dollars. By 2018, there was 70% increase in medical mobile apps, and it becomes 1.5 trillion US dollars. So I will conclude with my presentation with these words that technology and Internet of Things is the future of engineering. If you opt this, you will be the leader in the market, or you will be a competitor in the market at least. But if you be in the position of general manager of Nokia. Thank you very much. Thanks a lot.
Okay, thank you so much, Dr. Safik, for your wonderful presentation. I can understand that with the IoT in Industry 4.0 will be very beneficial for companies, and but the concept has to be implemented well to make a good quality of the products, and also it's not very costly for the customer, right? Okay, thank you so much for the presentation. Maybe if I check on the chat box, we have several questions for each of our speakers here. To look at the time, I think I just want to choose some of the question in this chat box, and maybe I will read it to each of our speakers here. Is that okay? Okay, maybe I will read the first question for Professor Jamal. You still here, Professor Jamal? Sorry. Yeah, there is a question from Mr. Gefra. He asked about how to adapt the resiliency strategies maybe in Southeast Asia, especially in a higher risk hazard cities areas, maybe Indonesia included, Japan included, maybe, but it's not in Southeast Asia, maybe Malaysia, Philippines, I think. Okay, would you please?
Yeah, I think in terms of the resiliency, if we deal with the high risk, I think one of the thing is one is what they call as the basic of planning rules, which is more on we need to regulate like certain areas where there is high risk, then those are the areas that we shouldn't allow for development, because sometimes what happens is that if example like in Malaysia, there are certain areas with very high risk and then they still want to do the development. Okay, we need to understand in terms of the resiliency that certain areas, like maybe some developers say, okay, in Hong Kong they're able to do on the hill slope and things like that. Why can't we allow it in Malaysia? But we have to look at in terms of the weather as well and the soil. Okay, if it is rocky, then maybe easier to build it. But if the soil becomes loose easily during rainy season, then that is something that we should not allow that to happen in our cities. So in terms of one is to avoid the high risk area in terms of like doing the development. And then perhaps I think if I can share like what I understand from Jakarta is that there is start to become the resilient city. Jakarta is that what happened is like become like sinking city. So sinking city, I think that's part of the reason like they have to move to Kalimantan, that is that like the groundwater, if it's extracted beyond the capacity, then it start to have a problem of that. So one is regulation to ensure that, okay, to make it more resilient. Two is on the infrastructure to deal with that. Okay, when we talk about resilient, it's not just the city is resilient in terms of high risk or disasters, but also resilient one in terms of health. Okay, the city which is going to be resilient is one is that is able to take care of the health of the population. So the basic infrastructure is still the main thing for the city. Provision of safe water supply and good sewerage system. That is the basic. Okay, and mention about the regulation. And the third one, really to make it resilient in terms of the social and other aspect. This is the time like where the city can adapt more on the like Dr. Shafiq mentioned just now on the IR 4.0. There's a lot of these tools now which is available, like for us to be able to reach out more to the people in the city using the new technologies. Okay, so that's my answer on the resilient city. I see. If I may go on, there's another question just now related the strategy. dealing with the COVID-19 here. And the question if there is a specific city in Malaysia that has been able to do that. I will have to answer at this stage, not yet. Not yet, simply because now what happened is that we are still unable to get out of this. The pandemic is getting worse in Malaysia. So we haven't had really a chance really to reconfigure for our city now. What we are doing is more like as battling the fire. Okay. So how can we reduce the cases, which is increasing very rapidly now? So many of government offices are still not open. We are working kind of mostly work from home, and then if the offices just open, maybe like less than 10% of the workforce come to the office. So we have not really gone into that to implement the strategies. But what I say that in the future, once we are able really to focus on this one here, I would say is the strategy of the smart city is the one that is something we can do in terms of the forms and function of the cities. Okay, so this is related back again to Dr. Shafiq mentioned just now, like the Internet of Things. Okay, the smart city incorporate a lot of these things. Okay, so that you are able to do it, medical advice through online. Okay, and now like in Malaysia we have the pharmacy drive-through. Okay, and also in terms of now in Malaysia we have what they call a field hybrid intensive care unit, which is really hospital which is like set up in such a short time. So this is the thing now, what we say there's emergency measures to deal with the COVID. But beyond this, how are we going to do this one? Then, so this is something that one thing that we can do, because we have been following the so-called, after industrial revolution, then we start to separate our zoning that in a way that we started to have the urban sprawl, people move further out to the suburb, and then they commute to the city. Okay, when they want to get the facilities, they have to commit to all these places. Okay, so separation of the land use. Okay, which was okay in the 18th and 19th century because the industries were very polluting. Okay. But now what happened is that when you start of the separation here, when we start from the so-called lockdown here, now like you cannot go beyond 10 kilometers. Like in Malaysia, you cannot go beyond 10 kilometers from your home. Okay, you want to buy something, anything like that, then what happened is that when people already started moving further away from important facilities, now they're having a hard time. So this is I mentioned just now, but for us to revisit again some of the planning practice and theory. And one example is what they call as a neighborhood unit. Okay, the garden city concept. You have the neighborhood unit, so like your place of employment, your place of everything that you need. Okay, your commercial area are all within a short distance to one another. So that if like you have the pandemic like this one here, you don't have to travel far. You can get basically what you need within your area. And one of the things we can do this one is that like back to this morning when I look at the MRT Jakarta and then look at Malaysia, and of course it has been done in Japan, like the transit-oriented development, that we start to look at the density where it's enclosed within a small area, okay, high rise, but it has all the needs of the community. Okay, that transit-oriented development. You live in that area, your commercial needs is within the area, and then your transportation so within the area. So in a way that if a pandemic comes, restrict your movement, and this is something that you'll be able to handle it easier. Okay, should it happen. So that is really my reply to the question just now. Okay, thank you.
Okay, thank you, Professor Jamal. Yes, indeed. In this pandemic, give us a lesson that build more dense community. I mean, all the facilities is just around the corner, just in a walkability measure. It will be very beneficial for the community, because like if we use, as you said, in the past time industrial era, we have to have some distance from industry to housing to other facilities. It's really beneficial, but now it's shortcomings in this pandemic era. Yes, thank you, Professor Jamal. So you have answered 2 questions from the chat box, and then maybe I'll move on to Professor Heki. You have a question from Mr. Prama here. Is there a way to use knowledge related to ionospheric disturbances and continuously operating reference station for disaster mitigation, especially related to earthquakes, volcanic eruption, and tsunamis to minimize casualties?
Oh yes, that's a very important point.
Yeah.
And once I wrote a paper in which I reported some anomalous behavior of ionosphere shortly before an earthquake. But that is very certain, but it is difficult to apply that for practical earthquake prediction. So one practical thing is that large earthquakes may make ionospheric disturbance 7 or 8 minutes after an earthquake. And that is earlier than the tsunami arrival at the coast. So that means if we could catch the signal in ionosphere 7 or 8 minutes after an earthquake, so we can issue a warning for large tsunami, because the amplitude of the disturbance tells us about the size of an earthquake. So that is one way to use GNSS array like CORS for tsunami disaster mitigation. And I think many groups in the world are already studying that, including my group. Thank you.
Oh, okay. For the answer, Professor Heki. Okay, you already answered for the question from Dr. Martina, so maybe I will move on to Dr. Shafiq. There is a question for you here. The same from Mr. Taufik, is the same between automation and robotics? And what's the difference between automation in the industry 3.0 and 4.0? Would you please?
Let me explain you briefly. Most of the people mix robotics with automation. Robotics is a sub-part of automation. It is about design and development of the robots which work for a very specific purpose. But in automation, you use the currently existing machines in order to perform a specific task. You may use a robot to automate those machines. Like you have to pick a material from one place and you have to place to another, you may use a robot. So overall, this is automation, but you are using a robot for that purpose. So robotics is a very specific field, and in automation, you may use robots or you may automate without using the robots. Suppose you use a conveyor. Instead of manually transferring the material from one place to another place, you may use a conveyor belt and you put like goods on the conveyor belt and transfer to the other point, the required point. And regarding automation in Industry 3.0 and Industry 4.0, in Industry 3.0, the automation was based on manual interventions. Like I want to automate some machine, I want to perform a specific task through automation. But in Industry 4.0, we call it intelligent automation. Like we use the data, we make intelligent decisions on the basis of the data. And it is not on the basis of human interventions only, but it is based on the machine-to-machine interaction. like machine coordinate with each other. If there are some problem, the data is transferred to the central platform. And that automation, like if a robot, suppose we are using the robot for that automation purpose, instead of a human interfere and change the operation of the robot, the machine itself, the central part itself, give different direction to the robot to perform a different task. So this is the difference between Industry 3.0 and Industry 4.0 automation. Industry 3.0 is manual automation, you may say. Like I want something to perform, I automate that part of the machine, that part of the work. But in Industry 4.0, it is not me. It is based on the data. Machines will decide, and machines will coordinate and interact with each other.
Okay, thank you, Dr. Shafiq, for your clear explanation on that question. Is there any more question for Dr. Shafiq here? Because Dr. Shafiq will do his Friday prayer. So he will leave our webinar earlier. Is there any more question from the participant here to Dr. Shafiq before he leaves this meeting? Okay, I think that's no more question for Dr. Shafiq from the participants. So thanks a lot, Dr. Shafiq, for your attendance in this webinar and your precious insight in this webinar. Thank you so much again. And maybe if you like to go to the Friday prayer, you may leave this meeting.
Yeah, thank you very much. And thanks to everyone, all the participants, and thanks to the organizers for giving me this opportunity. Thanks a lot once again. Assalamu alaikum.
Waalaikumsalam. Thank you.
Waalaikumsalam.
Okay. I think I've read all of the question in the chat box. Do we still have time, Miss Leanda? Or sorry? Are we finished, or we still have time for the question and answer session?
No, we don't have the time for the question and answer.
All right, thank you.
Yeah.
Okay then. I will close this session then. Thank you for Prof. Jamal. That's wonderful insight from you, and also Prof. Heki. That's new information for us too about tools that you are research about, studied. And thank you for all the participants and the questions you dropped in the chat box. And thank you for all the organizers to let me assist this webinar. And then I will close this session and I'll give it back to Miss Leanda.
Thank you very much, Ibu Deyu. And now we reach end of this occasion. Reminding to all participants, please be willing to fill out the attendance on the link in the chat box. Maybe the committee will be reassign the link on the chat box. And before we say goodbye, could we take a picture? Could we? Panitia boleh tolong dibantu untuk take a picture ya. Sudah siap?
Oke.
Oke, saya hitung 1, 2, 3. Once again. 1, 2, 3. Okay, ladies and gentlemen, from the depths of my heart, I do apologize for my mistake in presenting this event. Thank you very much for your kind attention, and keep healthy and stay safe. Thank you very much, everyone. Goodbye. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much.
Thank you very much, Prof. Jamal, Prof. Kosuke Heki. Yeah.
Prof. Sufyan Shah,
Really
thank you very much.
Yeah.
Okay.
See you next time, Professor.
Inshallah, we meet next time.
Yeah.
Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Good afternoon, everyone.
Yeah.
Many thanks for the attendance.
Thank you.
Udah orang Indonesia semua, Pak Rusfi.
Terima kasih Bu Laili, Bu Dayu, Pak Dekan, Pak Rusfi, terima kasih.
Terima kasih, maaf ya kalau saya ada salah-salah. Maaf.
Saya yang minta
Terima
maaf
kasih.
kalau banyak salahnya.
Terima kasih Lianda, terima kasih Bu
Sama-sama,
Dayu.
izin live ya Bu.
Terima kasih Bapak Ibu.
Panitia stay di
semuanya.
sini ya.
Iya,
Terima kasih
boleh
banyak para peserta, para narasumber, Pak Rusfi. Mbak Bunga, live on YouTube-nya boleh di stop.